given 2x to the 5th minus 4x cubed plus 2x minus 4. We're not asked to do any math with this one, and it's one of the easiest ones, but yet a lot of you on the first test missed this one. So we've got to not miss the easy ones especially. So how many terms does the polynomial have? What is a term? Somebody tell me. A number or variable separated by plus and minus signs, right? So how many terms does this one have? Let's count. 1, 2, 3, 4 terms. So terms, number of terms is 4. Very good. All right. How many roots does the polynomial have? This one's easy. It's called the fundamental theorem of algebra, which sounds fancy, but it's easy. What do you look at? You're all on the right track. I'm hearing the number. What number? Just be more specific. I'm sure you're right. The highest power. Perfect. Thank you. We look at the highest degree. So looking at this polynomial, the highest degree is degree 5. So if we solve this one, it would have 5 roots. 5 x-intercepts, 5 zeros. They're all called, it's the same thing called something different. Roots, zeros, x-intercepts, all mean the same thing. Very good. All right, and then what's the constant? Coefficient. Constant coefficient. Well, what's a coefficient? It's the number in front of the, what? Variables. It's the number in front of the variables. So 2 is a coefficient, negative 4 is a coefficient, positive 2 is a coefficient, and negative 4 is a coefficient. Okay, well then what's the constant coefficient? Negative 4. Very good. Negative 4. Does everybody see how this is our constant number? Yeah? That's the constant coefficient. So I'm going to ask a different one. What's the coefficient in front of our degree 2? 0. Good. There's not a degree 2. Does everybody see how there's not a degree 2? What's the coefficient in front of our cube? Negative 4. What's the coefficient in front of degree 5? 2. Okay, so make sure we can keep doing those throughout the year. Questions on that? Okay, that was a good one. Hopefully it was a good reminder for you. Okay, let's get started. Okay, so because this is a long unit and we tend to get to the review and not be able to do all the problems we learned in the beginning of the unit, I'm going to make it a goal to every day quickly go over a few things that we've learned in the unit so far. So for this part, you don't need to take notes. I want you just looking. You have notes on all this. We've learned this. I just want to go through this one and solve and review what we've learned in this unit so far. So it's going to go a lot quicker than if I was teaching it, so just look with me. So let's go through it. It says solve 3-1, we learned how to solve a radical equation. Okay, so everybody look at this. It is a radical equation. That 2/3 power is a radical in rational exponent form. So we know to solve radicals, we have to isolate the radical. So what do I do first? Good. Add 2 to both sides of the equation, leaving me with 2 times x plus 3 raised to the 2/3 power is equal to what? 8. And now we're solving the radical equation. Now first, what should I do? Good. Divide both sides by 2. I'm isolating the radicals. Divide both sides by 2. So then that leaves you with x plus 3 raised to the 2/3 power is equal to 4. Everybody remembers doing this, right? Yes, Ms. Christensen, we remember. How could we forget such a fun thing? All right, so continuing this, we've isolated the radical. How do I get rid of this radical? Good, you raise both sides to the reciprocal power. Reciprocal means flip. So raise both sides to the 3/2 power. Okay, so on this side, we know that the reason we did that is because that, when you raise a power to a power, you multiply. So that would multiply to be 6/6, which is 1. So left on the left side is x plus 3, which is equal to, and you'll take your calculator, 4 to the 3/2 power. Do it. 4 to the 3/2 power. 4 raised to the parentheses, 3 divided by 2. Everybody practice it. What do you get? 8. Was it an even root? Roots are on bottom, just like our picture of our flower. The roots of a flower are on bottom. Roots are on bottom. Was it an even root? Yes. So what do we need to add in front? Plus and minus. Does everybody remember learning this? Then we just split it up and solve each of them individually. So we have x plus 3 is equal to positive 8. X plus 3 is equal to negative 8. And then in each case, we solve for x, subtract 3, x is equal to 5, subtract 3, x is equal to 8, 9, 10, 11, negative 11. Both of our answers, we would check it to check for extraneous solutions. You plug those back into the original. I'm not going to take time to do that. Any questions on that? You would need to check your answers though. Okay, moving on. In 3-2, we learned function operations. Let's go through and do each of these. Given f of x is equal to x minus 3, g of x is equal to x squared, let's do f of x times g of x. That would be x minus 3 times g of x, which is x squared. F of x times g of x, right? So from here, what would I do? I'm looking for a certain word. Try it. Give it a try. Distribute. We would double distribute. X squared times x is x cubed. X squared times negative 3. Negative 3x squared. I'm going to ask someone in this class in particular if we can add these two things together. Dylan, can I add these two things together? X cubed minus 3x squared. No, not the same degree, not like terms. So this is where we'd stop. Very good. Okay, g of x minus f of x. All right, this is the one we have to be careful. Subtraction, we have to be careful. So we're doing g of x, which is x squared, minus f of x. So subtract that. So subtract all of that. So I put it in parentheses because we know we have to be careful with subtraction, right? Well, we are not going to miss this on this test. Okay, so really what we technically have is a negative 1 there. So negative 1 times x is negative x, negative 1 times negative 3. Positive 3, very good. We drop down x squared. Combine my terms. Can we combine any of those? Nope. There we go. We're done. Any questions? Domain and range though. Domain. With this one, is there any problem areas? No root, no roots, and no bottoms of fractions. So domain is all real numbers. What's our range? Well, we could graph it and look at it. It's a cubic. So can anyone tell me what a cubic's end behavior would be? All real numbers. Did you say all real numbers? Yep, you're right. All real numbers. Okay. All right, domain on this one. Do you see any problem areas? Nope, no problem areas for our domain is all real numbers. I won't make us do the range on this one. But we could graph it, find the lowest point, right? Lowest point, it's a quadratic, so it's going to have a lowest point and it's going to grow to positive infinity. Okay. All right. Finding inverses. This is what we learned in 3-3 and then we'll be to what we're learning today. So finding inverses, in 3-3 we learned that we're given a function. The first thing we'll do is, well, I'm going to rewrite it. Instead of f of x, y is the same thing. Negative 1/6 x squared minus 3. The first step, somebody tell me, what's the first step in finding an inverse? Good, change the x to y and y to x. X is equal to negative 1/6 y squared minus 3. And then from there, we just solve for y piece by piece. What's my first step? Add 3 to both sides. Now I'm going to ask you. There's someone in here specifically I'm going to ask. I'm going to ask that everybody, you tell me. So I'm going to have you think for a second. Is this 3x or is this x plus 3? Everybody think by yourself. Is this going to be 3x on the left or x plus 3? Ready, set, go. Tell your neighbor. What's it going to be? Okay, x plus 3. Very good. I heard some good things. So x plus 3 is equal to negative 1/6 y squared. Yes, Bill. Yes. Yes. Are you Cole? Yeah, that was for you. But you guys, I watched you when I said tell your neighbor, and I saw you tell her right. So I'm like, yeah, we're good. Good. Very good, Cole. Okay, from here. Be careful. This is a common error. What do we need to do first? What's our next step to get y alone? Good. Get rid of that negative 1/6. How can we get rid of that? Good. Multiply both sides by negative 6. Multiply both sides by negative 6. When I say side, I mean that entire side. Do I need to put it in parentheses? Yes. Guys, look. Think about it. Negative 6 times negative 1/6. If we multiply fractions, we multiply straight across. What do we get on top? 6. What do we get on bottom? 6. What do we get? 1. Does everybody see how that got rid of our problem there? All right, so right now we have this. Now I'm going to leave it. That's fine. We don't even have to distribute it through. Leave it right there. That's equal to y squared. Now what do I do? Square root both sides of the equation. Very good. So we square root both sides, so we have negative 6 times x plus 3. What do we need to not forget in front? Good, plus and minus. So we have plus and minus the square root of negative 6 times x plus 3 is equal to y. Okay, is y completely alone? Yes. The only thing I would have us do in this one, last step, would be to pull out the negative, and what do we have on the outside of the root? I. So I square roots of 6 times x plus 3. You can leave it like that for the inverse, and that's equal to y. So does everybody see what I did there? That would be how they would write it on an ACT or an end of level. Right there. So f inverse of x is equal to that. F inverse of x is equal to plus and minus I square roots of 6 times x plus 3. And domain, man, we won't go through that. Anyways, we're good with domain and range, right? Okay. All right. I just wanted to go over what we had learned so far just because it's been a long weekend and we got to remember those things. Okay, so today, 3-7, not correct. What the heck was I doing there? This is 3-4, everybody. 3-4. Let's get started. Here we go. So today we're going to be solving rational equations. What does rational mean? In general, rational.
Makes sense.
Rational, makes sense, okay. So if you're a rational person, it makes sense.
It keeps going on and on and on, right?
No, that's right. Yeah. You're on the right track, so you're saying, you said, a whole number is irrational. But whole numbers are not necessarily rational. I mean, rationals are always whole numbers. No, negatives are still rational. Guys, rational means can be written as a fraction.
That's what I meant.
Okay, can be written as a fraction. So guys, you tell me, is 1 and 6 a rational number?
Yes.
Is 6 a rational number?
No.
Yes. Yes, that's 6 over 1. Okay, is negative 6 a rational number?
Yes.
Yes. Is negative 1/7 a rational number?
Yes.
Yes. Okay, we're good with rationals. Okay, so today we're going to be solving rational equations. So that just means we're going to have an equation that's dealing with fractions where our variables in the bottom of our fraction. All right. So here are the steps to solving a rational equation. If you want to take a picture of it, I'm fine. If you want to try to quickly write it down, I'm fine with that. But these are the steps. So these are the step-by-step instructions. First thing we're going to do is factor the denominators to find the least common denominator. So we're going to have a bunch of rationals. It's going to be in the form of an equation. We're going to factor all the denominators of the fractions to find the least common denominator. Then your second step is to manipulate each piece so that they have the exact same denominator, so that they have a common denominator. It has to be exactly the same. So we're going to change it, we're going to manipulate it correctly so that we have a common denominator. And then third, we'll simplify and solve. And the nice thing is once we have a common denominator, we don't even have to use it anymore. We won't use the bottom of our fractions, we'll just take the top and solve. So that's kind of nice. So we'll simplify and solve using the numerator, which means the top of our fraction. And then we'll check our answers for extraneous solutions, because we're going to be manipulating these quite a bit, some of them. So we've just got to check our answers. All right. Questions? Yeah, I understand that, the instructions don't make a whole lot of sense till we practice them. All right, you all have them down just about. Another couple seconds, and then we'll just start practicing. Now, all my examples are going to come from your worksheet today. So, you can do them on there, or you can do them on your own sheet of paper. You might need more room. It depends. All right, here we go. First example. So everybody look at number 1 on the worksheet. Now look at it. This is a rational equation. Notice in the bottom of our fraction is a variable. These are in the form of a fraction. We have some variables, and it's an equation because of the equal sign. So we're trying to solve this. So guys, what we're trying to do is we're trying to find the value of m that will make this a true statement. Now we're going to do this using algebra, okay? We're just going to do this using algebra. So first of all, our first step is to get a common denominator using the least common denominator. So finding the least common denominator just makes it easier on you because you're not using these huge numbers. So we want to find the least common denominator. So common denominator means the bottom's going to be the same. So we have a 6 and an n. Okay, so factored form, these are factored. 6 and an n. We have a 6 and an n. In this piece, we have a 6 and an n. Have we already listed that? Yep. This one has an n. Have we already listed that? Yes, right? So our least common denominator is 6n. So now we're going to go through and fix every piece that we need to so that we all have the bottom to be 6n. This one already has 6n. We don't have to fix it. This one already has a 6n. We don't have to fix it. This one has an n. What does it need? 6. So we're going to multiply the bottom by 6. But if you do that to the bottom, you must do that to the top, or else you've changed things. So really, we're just multiplying by a fancy 1 here. Now check your bottoms. Are they the exact same? 6n, 6n, 6n. Yeah? We have a common denominator. So now we don't even have to look at it. Because we have a common denominator, we'll go through and solve using the numerator. So up here we have n minus 6. Then we have minus 1. Is equal to, this is 1 times 6, right? Which is 6. And from there, we'll solve for n piece by piece. Does everybody see what I did? Got a common denominator. Then I'm using the top to solve. Okay, so then I'm going to combine like terms over here on the left. So we'll have n minus, you tell me, negative 6 minus 1 more, people. Okay, come on. Negative 7 is equal to 6. Now what am I going to do to solve for n? Add 7 to both sides of our equation. So n is equal to 13. Very good. So now we'll check our answers by plugging 13 back into our original equation. So we're going to have 13 minus 6 over 6 times 13 minus 1 over 6 times 13 is equal to 1 over 13. So I just type it in using my calculator. You've got to use parentheses where necessary. So sometimes it helps to simplify this piece. Type that into your calculator, change it back to a fraction, subtract this, and then see if it equals 1 over 13. If you check it, then it does. You get 1 over 13 is equal to 1 over 13. So the answer checks out, so we get to keep the answer. Is everybody okay with that? Okay, so we just did number 1. Any questions on number 1? Are you comfortable to try number 2? Well, you should be, so let's try it. Let's get comfortable trying number 2. So everybody look at number 2 real quick. I'm not going to go through the whole thing with you, but I will talk about what's the least common denominator in this one. 4b squared. So go through and manipulate these so that they all have a 4b squared in the bottom. If you do it to the bottom, you've got to do it to the top. So everybody try number 2 by yourself. If you need to work with your neighbor, do it. But try. All right. Did anybody get the answer negative 4 over 11? Okay, that is the correct answer. So let's go through it and see where you went wrong. Okay, and I already know where probably most of you went wrong. So looking at this, most of you were able to say, okay, so our least common denominator is 4b squared. So we've got to change all of the denominators to be 4b squared if they're not already. So this one right here needs a 4. We multiply the bottom and the top by 4. And then looking at this one, we already have 4b squared. Right here, it needs a 4. So we're going to multiply the bottom and the top by 4. Okay, so right here, now that we have a common denominator and we're sure of it, we can ignore the bottom and just use the top. So we have 4 times 1, which is 4. So we have 4 is equal to, right here we just have our 1. Then we have 4 times all that stuff, right? 4 times all that stuff. So we got to be careful. So we're going to distribute it through. 4 times b is 4b. 4 times 2 is plus 8. Now what was in front of that? A subtraction sign. So aren't we subtracting all that stuff? Aren't we subtracting all that stuff? Yes. Okay, so is that where most of you made your error? Yep. All right, so with those negatives again. All right, does everybody see why I put this in parentheses? We're sure. Because I'm subtracting all that stuff. So really we have 4 is equal to 1, and then we have, technically if we needed to, we could write in our negative 1. Negative 1 times 4b is negative 4b. Negative 1 times positive 8 is negative 8. So then from there, I'm going to combine like terms. 4 is equal to 1 minus 8. 1 minus 8. Negative 7, very good. Negative 7 minus 4b. Then what would I do? Solve for b. Add 7 to both sides. So I get 11 is equal to negative 4b. And then what would we do from there? Good. Divide both sides. Oh, I wrote that. Divide both sides by negative 4. So I wrote that upside down on accident. So b is equal to 11 over negative 4. How many of you got that right the first time? The first time, sorry. Because I messed y'all up and I didn't give anyone credit. Okay, alright, does everybody get that? So I accidentally wrote negative 4 over 11, but it was 11 over 4. Okay, awesome. Questions on that? Then I would check my answers by plugging it back in. I did check this one. It was kind of complicated to check it, but you would need to. And I got the correct answer, so we're good. All right, any questions on that? Okay. Number 3, let's go through number 3, and then I'm going to let you work for a second. Number 3 and 4, and then I'll let you work. Here we go. So we have 4 over 3r plus 1 over 6 is equal to 3 over 2. First thing we're going to do is find our least common denominator. Okay, so find our least common denominator. I would factor this. A couple different ways we can do this one. I would factor each piece. So looking at this, 3 and r already factored. 6. 6 is the same thing as 3 times what? 3 times 2. Okay, so I'm going to rewrite 6 as 3 times 2, and this one has a 2. So now let's go through and list what each of them have so that we know our common denominator. This one has a 3 and an r, so we need a 3 and an r. All right, this one has a 3 and a 2. We already have 3 listed, but what do we need to add? 2, so, and then we're going to multiply 2 in. Does everybody see what I'm doing? Going through each piece and getting my least common denominator. This one has a 2, we've already listed 2. So, our least common denominator is going to be 6r, right? Okay, so we've got to make each of these 6r. Each of these have got to be 6r. So we're going to manipulate them correctly. This is 3r. How can we make it 6r? Multiply the bottom by 2. If you do that to the bottom, you've got to do it to the top. Okay, this one's 6. It needs an r. So we're going to multiply the bottom by r. If you do that to the bottom, you've got to do it to the top. Then over here, this is a 2. We need it to be 6r. So we're going to multiply by 3 and what else? 3 and r. So I'm going to do that to the top and bottom. Now that we have a common denominator, we can ignore the bottom of our fraction. So just double check that 6r, 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 we're good. So now we can ignore the bottom, and we can just use the top to solve. So 2 times 4 is 8. So we have 8 plus 1 times r is r. So 8 plus r is equal to 3 times 3r is 9r. Questions? Solve for r piece by piece. Subtract r from both sides of the equation. 8 is equal to 8r. Then divide both sides by 8. So we get 1 is equal to r. R is equal to 1. We plugged it back in, we'd have 3 over 4, 4 over 3 times 1 plus 1/6 is equal to 3/2. So you'd be doing in your calculator 4 over 3 plus 1 over 6, and then you better hit math, enter, enter, change it back to a fraction, and if you check it, you'll get 3/2 is equal to 3/2, which is a true statement. So we get to keep our answer, r is equal to 1. Okay, let's do number 4. Number 4. And then I'll let you work on practice view on your own. Okay, so this is why we went over factoring the other day. This is why, all for this moment. So, we have number 4, 5 over n squared plus 7m minus 1 over n plus 7 is equal to 6 over n squared plus 7. So in our steps to solving, the first thing we do is factor our denominators so that we can find our least common denominator. So let's factor each piece. So looking at this piece, looking at the bottom, let's factor it. Well, it's quadratic, but what do we have in common in the very beginning? and m, right? So let's factor out an m. Well, what's left? Divide each thing by m if you must. M squared divided by m becomes an m. Positive 7m divided by m is 7. So I factored that. Now I'm going to factor this piece, m plus 7, and that's done. Right here we have the same thing. M squared plus 7m, factor out an m. Left is m plus 7. So now we can figure out our LCD, our least common denominator. So let's go through and list what we need. An m, we need an m, we need an m plus 7. Okay. Well, right here we need an m plus 7. We've already listed that. We need an m and an m plus 7. Well, we've already listed that. So our least common denominator is m times m plus 7. So now that we know our least common denominator, we'll go through and fix each piece of our equation to have that same denominator. All right, so let's look at this first piece. We have our m and our n plus 7. Do we need anything? Nope, so this one's good. This one, m plus 7, what do we need? M. So we're going to multiply the bottom and the top by m. And then right here, we have an m and an m plus 7. We don't need to fix this one. So now check your common denominators. Make sure they're all the same thing. M times m plus 7, we're good. M times m plus 7, good. M times m plus 7. So now that our denominators are the same, we can ignore it and just use the top to solve. So what we're going to have here is 5 minus 1 times m is minus m is equal to 6. And then solving for m piece by piece. Does everybody see how I got that? 5 minus 1 times m is minus m is equal to 6. Now solve for m piece by piece. Subtract 5 from both sides. So I have negative m is equal to 6 minus 5 is 1. Now I had a lot of people ask me this the other day. Well, I have a negative n. How do I get m alone? Divide by what? Good, negative 1. So I'm going to divide both sides by negative 1. So that's going to be m is equal to 1 divided by negative 1 is negative 1. And then we could check it by plugging it back in. I have done that. It does work. You really have to check your answers though. Any questions on that? Are you ready to practice on your own? I think you are. No questions? Okay, awesome. Do 6 through 9. So do 6 through 9. So yes, you're skipping number 5 for now. If you can do number 5, go for it. I'm going to do an example like it later. But if you can do number 5, go for it. But you can definitely do 6 through 9. Work really hard. Okay, looking at this one, we have 1 over 2x plus 2 plus 5 over x squared minus 1 is equal to 1 over x minus 1. Our first step is to factor all of our denominators. So let's look at this piece very carefully. The most important thing is factoring, guys. The most important thing is factoring. So looking at 2x plus 2, do we have anything we can pull out?
2.
A 2. If we pull out a 2, we divided each term by 2. So left would be x plus 1. Does everybody understand that?
Yeah.
Okay, moving on. We have x squared minus 1. Okay, so we've got to factor this one. It's a quadratic. There's no quick way. There's nothing in common, but we can factor it, guys. We know how to factor quadratic. So I'm going to do it right here and then erase it. So we're going to do what multiplies to be a times c, and adds up to be b. Hey, don't yuck me. This is a quick factoring one, right? I could have been a lot meaner. So we're looking for what so what is a? What's b? 0. What's c? Okay, so a times c would be 1 times negative 1. What multiplies to be negative 1 and adds up to be 0, right? Factors of 1. 1 times.
That's the 1.
So negative 1 and 1. Doesn't that? Are those our factors? So our factors are negative 1 and positive 1. We can quick factor because a is equal to 1. So this is going to factor be x minus 1 times x plus 1. Now that wasn't that big of a deal, so don't cry like a wee baby. Okay? Okay. So can I erase that?
No.
Okay, not yet? Okay. Okay, I'll leave it up for a second. So then this became x minus 1 x minus 1 times x plus 1. Okay. And then factoring this one, x minus 1, and we're done, right? That one's already factored. Okay. So let's list out our LCD. This one has a 2, we need a 2. This has an x plus 1, we need an x plus 1. Alright, x minus 1, we also, why did it just go? Right. Seriously? Okay, so we have an x plus 1, and then we have an x minus 1. Are you guys following or paying attention? Okay, so that's our LCD. Are we all okay with that? Okay, let's go through and fix all of these. Okay, so quickly fixing. Alright, this one. So this one has a 2 and an x plus 1. What does it need? So we're going to multiply the bottom by x minus 1 and the top by x minus 1. Okay, this one was x minus 1 times x plus 1. What are we missing? No, we got that. 2. Multiply the bottom and the top by 2. Is everybody following? Okay. And then x minus 1. Got that. What do we need? A 2 and then... So we multiply by 2 and x plus 1 to the top and bottom. 2. And make sure you put it in parentheses. I like that. Alright, now our bottom is the same, so now we can focus on the top. 1 times x times negative 1. Let's distribute that through. 1 times x is... You okay back there?
Yeah.
1 times negative 1. Negative 1. And we have plus 5 times 2 is... So plus 10 is equal to... This is where we have to be careful. 2 times 1 is... So then we're doing 2 times all that, right? So 2 times, because of those 2 times x plus 1, let's distribute it through. 2 times x is 2 times 1. And then from there, we'll solve. Combine like terms. So we have x, negative 1 plus 10 is plus 9. Is equal to 2x plus 2. From here, don't be afraid. You can combine things by bringing them from one side of the equation to the other. Correctly, though. I'm going to subtract x. So I have 9 is equal to 2x minus 1x is just x, plus 2, minus 2, 7 is equal to x. Any questions? Secondary math 3, well, I told you it wasn't going to be easy. So yes, this was a long problem, but you'll get used to it if you're not already. All right, so do problems 5, 12, 13, 14, 11. Ready, set, go. Basically, they're